Let us complete these chemical reactions together. You can take out your chemistry notebooks and complete them together with me. Let's start with the first one. I'm going to give a trick. See, whenever we have an alcohol with a dehydrating agent, okay, and then we heat it, then you will get an alkene. That means dehydration takes place whenever we have a dehydrating agent like concentrated H2SO4. Okay, and then trick number 2. See, when we have a primary alcohol with an oxidizing agent, then we get an aldehyde. And furthermore, aldehyde will be oxidized to carboxylic acid. Okay, and when we have a secondary alcohol with an oxidizing agent, then we get a ketone. These are the 2 tricks. So based on these, let us do the first one. See here, we have a primary alcohol, N-propyl alcohol, with what? Sulfuric acid. This is a dehydrating agent, okay? So we have a dehydrating agent. Then what happened? Dehydration takes place. That means there is a loss of water molecule. So we get an alkene, CH3, CH double bond, CH2. We have a loss of water molecule. What is this? Propene. Okay, so you write here propene, CH3, CH double bond, CH2. Next, what you have to do? You add hydrogen bromide and you have to follow the Markovnikov rule. See here, hydrogen bromide, follow Markovnikov rule. That means here you have positive part and negative part. According to Markovnikov rule, the negative part goes to the carbon which is less hydrogenated, and the positive part goes to the carbon which is more hydrogenated. Then what do you have? You have CH3, CHBr, CH3, CH3, CH3Br. Okay, what is this? Isopropyl bromide. Okay, next you are adding aqueous potassium hydroxide. So your bromine atom would be replaced by OH. So we have CH3, CH, CH3, OH. This is a secondary alcohol. CH3, CH, CH3, OH. Okay, it's your isopropyl alcohol. Alright, so the first one is done. Let us come to the second one. See here, we have isobutyl alcohol with a dehydrating agent. So again, dehydration takes place. CH3, CH, CH3, CH2, OH with a dehydrating agent. Okay, dehydration takes place. There is a loss of water molecule and you get an alkene. CH3, CH, CH3, sorry, there is no more H because dehydration has been taken place. Double bond, CH2. Okay, what is this? This is your alkene, right? And then next, here you have CH3, CH3, double bond CH2. You are adding HBr. You have to follow Markovnikov rule. That means the negative part goes to the carbon which is less hydrogenated and the positive part to the carbon which is more hydrogenated. And you have CH3, CH3, Br, CH3, 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 Br. This is your tertiary butyl bromide. And you add potassium, aqueous potassium hydroxide. Your Br is replaced by OH. Then we have CH3, 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 OH. This is your tertiary alcohol. This is your tertiary alcohol, okay? Tertiary butyl alcohol. Okay. Next, we have this one. See here. You have an alcohol, ethyl alcohol, with an oxidizing agent. Potassium dichromate in acidic medium acts as a very strong oxidizing agent. So what happened? A primary alcohol is oxidized to aldehyde. See, it is oxidized to aldehyde. CH3, C double bond OH. Alright, again, an aldehyde is oxidized to a carboxylic acid. Here we have a carboxylic acid which is an acetic acid. This is your acetic acid. This is your acetaldehyde. Okay, so let me start from this one. I have my acetic acid, CH3, C double bond OH, okay, with sodium hydroxide. See here, this is positive, this negative, negative, positive. So we have a water molecule, and then here we have O minus and Na plus, which is a sodium acetate. Sodium acetate. So you get here sodium acetate. And the next, what do we have? Sodium hydroxide with calcium oxide, and then we heat. In this case, see here, we have this one, sodium carbonate. And then from here, from this part, we have sodium carbonate. Now this hydrogen combines with this one to give methane. So you get methane, and you have here Na2CO3. So you get methane. Alright, now methane with chlorine in the presence of a light, okay, then you get what? Methyl chloride. You get methyl chloride, CH3Cl. And this methyl chloride with aqueous potassium hydroxide from here we have potassium chloride, and then we get a methyl alcohol. Potassium chloride, methyl alcohol. Methyl chloride. Okay. All right. We come to the next one. See, this is a secondary alcohol. So what happened? A secondary alcohol is oxidized to a ketone. Then we have acetone. What is this? Acetone. Acetone. So let's have a look here. Acetone, CH3, C double bond O, CH3. Now the first one is with this substance or compound, okay, a Grignard reagent. Remember, Grignard reagent. So this part is partial positive, this is partial negative, because oxygen is more electronegative than carbon. This is a metal, so this part is partial positive, this is partial negative. This one goes to attack the partial positive carbon. The electrons from this bond shift here, and this one comes here. So we have CH3, COMgI, and then here we have CH3, CH3. Alright, now what is the second step? H2O in the presence of an acid, okay? Acid hydrolysis. Then we have what? OH, CH3, CH3 plus MgOHI. Okay, so this is a tertiary alcohol. So altogether we have a tertiary alcohol. 1, 2, 3, 4. Tertiary butyl alcohol. Okay. All right, we come to the last one. See here, I have ethyl alcohol with thionyl chloride. See here, ethyl alcohol with thionyl chloride. What is this? Thionyl chloride. Okay, from here we have HCl, and then this, with this we get sulfur dioxide, and this chlorine forms a bond with carbon. So what do we have? We have alkyl halide, that is ethyl chloride, and then we have sulfur dioxide with HCl. Okay, and what else? We also have magnesium. So this is a metal. You get a Grignard reagent. What is this? A Grignard reagent, where a metal, that is magnesium, is bonded to carbon. This is a Grignard reagent. So what do we have here? CH3, CH2, MgCl. Alright, now next, this Grignard reagent, first it reacts with what? Formic acid. Okay, this is partial positive, partial negative, partial positive, partial negative. So the negative part, this one, goes to attack the partial positive carbon, and so the electrons shift here, and this positive part would come here. Alright, so what do we have? We have HCO, MgCl, and then H, and then we have CH2, CH3. What is the final step? Second step, we acid hydrolyze. So what do we have? In the same way, we have OH, H, CH2, CH3 with MgOH, Cl. What is this? This is your CH3, CH2, CH2OH, N-propyl alcohol. So you get N-propyl alcohol. Hence we are done.